In question 7, it says prove that if y is equals to 1 upon cos theta, then dy by d theta is equals to sec theta tan theta. Now, if y is 1 upon cos theta, we can write it as y is equals to cos to the cos theta cos minus 1 power theta. When we find dy by d theta, we can first also write it as cos theta to the power of minus 1. And then when we differentiate, we multiply minus 1 over here. And then we write cos theta as it is. We decrease the power by 1 and also write the derivative of cos theta, which is minus sine theta. So minus minus will cancel out and we'll have sine theta upon cos square theta. We can write this as sine theta divided by cos theta multiplied by cos theta. We know that sine theta upon cos theta is tan theta. So we can now write dy by d theta as tan theta and 1 upon cos theta is sec theta. So this will become tan theta sec theta. In part 2, it says prove the identity 1 plus sine theta upon 1 minus sine theta is as given. Now, if you have to prove this as what is given on the right hand side, to simplify this, we can start off by just multiplying the numerator and denominator with the conjugate of the denominator. So what this actually means is we can write it as 1 plus sine and we can multiply the numerator by 1 plus sine and the denominator by 1 plus sine as well. So expanding the numerator, we'll get 1 plus 2 sine plus sine square theta and divided by this will become 1 minus sine square theta. Now 1 minus sine square theta is cos square. So we'll have 1 plus 2 sine theta plus sine square upon cos square. Now we can divide each of the terms by cos square and write it as 1 upon cos square theta plus 2 sine theta upon cos square theta, or we can write it as cos theta into cos theta, and then plus sine square upon cos square theta. So 1 upon cos square, that will become, so that should become sec square theta, plus this will become sine theta upon cos theta is tan theta, and 1 upon cos theta is sec theta as we did earlier. So this will become 2 sec theta and tan theta, and this will become plus 1. But in the question, we have 2 sec square theta instead of sec square theta and minus 1 over here. So in place of 1, maybe we can use an identity. So the identity we can use for 1 could be, oh, sorry, a mistake. Sine square upon cos square is tan theta, tan square theta. So this will become tan square theta. And now we know that the identity for tan theta is, so sec square theta is tan square theta 1 minus tan square theta. 1 plus tan square theta. So that is tan square theta plus 1. So tan square will be sec square minus 1. So when we write sec square theta minus 1 over here, so we'll get sec square plus sec square, that will become 2 sec square theta. We already had 2 sec theta tan theta and minus 1. Now we have the identity that we had to prove. And now in the next part, it says, hence find the exact value of the integral of 1 plus sine upon 1 minus sine. Now we can use the identity over here, which is 2 sec square theta. So we have 2 sec square theta plus 2 sec theta tan theta minus 1. So we can write this in place of 1 plus sine upon 1 minus sine. And we have the limits pi upon 4 and 0. And now we have to integrate it. Now we know that the integral of sec square is tan theta. So in place, when we integrate sec square theta, we'll get 2 tan theta over here. For 2 sec theta tan theta, in part 1, what we learned was that the derivative of 1 upon cos theta is sec theta tan theta. Okay, so we can write it over here that the derivative of 1 upon cos theta was, let me just check it out again. The exact answer was tan theta sec theta. So keeping 2 as constant, the integral of tan theta sec theta should become 1 upon cos theta. And integral of -1 should become theta. So now we have the integral, which is 2 tan theta plus 2 upon cos theta minus theta. And now we can just substitute the limits. The first limit is pi upon 4. So tan pi upon 4, that is equals to 1. So this will become 2 plus 2 upon cos of pi upon 4 is 1 upon root 2. So we can write it as 1 upon root 2 minus, and this will be pi upon 4. And then we substitute the lower limit, which is 0. So this will be 2 tan 0 is 0 plus cos 0 is 1. So this will become plus 2 minus 0. Now we know that this is 2 minus plus minus 2. This, so 2 and 2 will cancel out. This will become 2 root 2. The root 2 will come in the numerator. So that will become 2 root 2 minus pi upon 4. And that will be our final answer.